Hi, I'm Grason. Today I'm going to tell you about who we are and what we do. Research in our group uses theory and computation to study mechanisms of self-assembly in soft matter systems. For us, the central question is how do soft matter building blocks, be they small molecules, particles, or proteins, self-organize into structures that are much better defined on length scales bigger than those building blocks. So one organizing paradigm for our group is the role of geometric frustration, or the misfit between the interactions and shapes of those building blocks. And what's surprising and often important in these systems is that misfit actually gives rise to better defined structures that are better controllable on large length scales. So the basic question for us is, can we use these principles to understand structure formation in existing biological systems, or in fact develop new engineering principles for programmable soft matter systems?
I'm Kyle Sullivan, and I'm a third-year graduate student in the Grason group. We're a theoretical and computational group with group members having a diverse array of backgrounds, from physics and chemistry to chemical engineering, and as a result we use a diverse set of tools. We'll tend to use mathematical modeling such as pen and paper, as well as computational modeling such as running simulations on high-performance computing clusters. While it's useful to have experience with both mathematical and computational tools, it's definitely not necessary to be an expert in either when joining the group. There are plenty of opportunities to learn from our group members, and there are absolutely things that I'd never heard of that I've had to learn. But overall, I'd say that we strike a good balance between doing math and programming.
Hi, my name's Ben Greenvall, and I'm a graduate student in the Grason group. Even though we each have our own individual projects, the group is incredibly collaborative. There's a huge exchange of information that goes on where people are very willing to share their unique perspective, be it on a technical problem or about life or careers. We have regular group meetings in the group too, where people are very willing to share feedback and plan your project with you, so it's really a collaborative environment. We meet regularly with Greg, and we're free to bring any ideas that we want to discuss related to our research, be it high-level planning or really diving into the weeds of a derivation or a computation. The group is also incredibly welcoming of questions and exchanging ideas, which I really appreciate as a newer member. You're completely free to ask silly questions, which I think leads to more productive science.
Hi, my name is Gunung. I'm a fourth-year physics PhD student in Grason's group. I want to talk about a feature of our group, which is that we have a lot of collaborations with other groups inside and outside of UMass. For instance, I'm working with Santor's group just a floor above my office. They often bring their new observations on their experiments to us. Then what we do is we build some simplified theoretical or computational models that describe the cool phenomena they see. Sometimes the theoretical and computational predictions we make can be tested experimentally too. This back and forth combination of theory and experiment can help give better physical understanding, and is also very useful to help people better understand our theory work.
Thank you for taking the time to come and learn about our group. We hope to see you sometime in Amherst.